Hello everyone, this is Wasim from Edureka and I welcome you all to this live session in which I'm going to talk about Python Pandas Library. So I'm sure most of you have heard about the Pandas library in Python, and it is an integral part of data analysis and serves as the building block of data analysis and data science. So let us take a look at the agenda for this session. But before that, let me get a quick confirmation if you guys can hear me or not. So if I'm audible to you guys, please type yes in the chat box. And now that I can see a lot of confirmation, let us go ahead and take a look at the agenda for this session. So first of all, I'm going to start with the basic introduction to pandas in Python, followed by data frames and series with examples. And then we will see how we explore the data using pandas. Moving further, we will learn pandas operations, merging, grouping, reshaping, etc. And then I will discuss time series and categorical data. After this, I will talk about plotting with pandas, and finally, to sum up this session, I will tell you about reading and writing files using pandas. I hope you are clear with the agenda. So let us go ahead and take a look at what exactly is pandas. So pandas is a Python library which is used for data manipulation, analysis, and cleaning. And Python pandas is well suited for different kinds of data, such as we can work on tabular data with heterogeneously typed columns. We can work on ordered and unordered time series data, arbitrary matrix data with rows and column labels. We can work on unlabeled data, and we can also work on any other form of observational or statistical data sets. Now I'm going to tell you how you can install pandas on your systems, guys. It's very easy to install Python pandas. You just go to your command line or terminal and just type pip install pandas, or if you're working on an IDE such as PyCharm, you can just simply type in pip install pandas in your terminal over there, or you can just open the project interpreter and add the library over there. Since we are going to work on Jupyter Notebook, I'm going to tell you how you can install Python pandas on Anaconda. So you just have to do one thing. So I'll just show you guys how you install Python pandas on your system. You open the Anaconda prompt. We'll wait for the prompt to set up. So you type conda install. It's already there in my system because I have already installed pandas since I've already worked on various data analysis projects, and it's a very integral part of it. Because to work on a data set, to read a data set, you require pandas, and it's just that you cannot work without pandas if you're working with any data related project. So this is how important Python pandas actually is. I'm going to tell you a few applications of pandas as well. So first of all, you can just say that Python pandas is an integral part of data, whichever project you're working on. So you can work on economics. You can use Python pandas for stock prediction. You can use it for recommendation systems. Then you can use it on neuroscience and statistics also. You can use it for, and then there is advertising, so many data coming from different platforms. You can just analyze the data using pandas, clean the data for irrelevant inconsistencies in your data. You can do that using pandas, and then you can use it for analytics as well. That's the very basic use of Python pandas that I can think of. So right now that we know how pandas actually is in Python programming and what it is used for, let's go ahead and take a look at the very integral part of pandas, that is data frames and series. We'll wait for this to install, guys. Meanwhile, I'll just tell you what are data frames and series, guys. So data frame is a two-dimensional, and the size of the data frame is mutable, potentially heterogeneous data, or we can call it heterogeneous tabular data. So the data structure, which is data frame, also contain labeled axes, which is rows and columns, and arithmetic operations align on both rows and column labels. It can be thought as a dictionary-like container for series objects. Now, what exactly is a series, guys? So a series or a pandas series is a one-dimensional labeled array capable of holding data of any type, which is integer, can be string, float, Python objects, etc. And the axis labels are collectively called index, and pandas series is nothing but a column in an Excel sheet. So let's just take a look at a few examples, and then you'll be able to understand this better, what I'm talking about, like pandas and series, what exactly they are. We'll be working on an example now. So I'll just take it to Jupyter Notebook, guys. So we have already created a Jupyter Notebook. If you are not familiar with Jupyter Notebook, guys, we have a full tutorial on how to use Jupyter Notebook, all the cheat sheet and everything. So you can just refer to those in our Edureka YouTube channel. So since I have already installed Python Pandas, I'm just going to import Pandas as PD, run this. I'm not going to face any problem running this command because I have already installed Pandas. Okay. So what this command will do over here, it's going to install the package, the latest release of Pandas for me. I think that's why it's not running. Okay, we have our first statement over here and we have successfully imported Pandas as PD. So I'm using the alias as PD. I hope you guys know what alias is. So let's just say I'm importing this library. So alias is going to be this one, that is PD. So for importing, I'll tell you why I'm using this. Now if I want to create a data frame, I'll just use df as my variable name for data frame. So I'm going to use the alias. Now when I type tab over here, okay, so this is how I can use my alias to create a data frame. So this is just to tell you how you use an alias. Now I'm going to show you how you can create a series and a data frame. So first I'm going to, I'll have to import numpy as well because I'm going to use it to create a null value. All right. So df is equal to, I'm going to make a series, so I'll just write it as s. All right. Series, and I'm going to pass a list of values. Let's say 1, 2, 3, 4, 5, 6. And I'm going to use my numpy now to create a null value like 8, 9, and one more value, let's say 10. So it's going to create a series. Now when I print s, so we have a series which has indexes which are already there and all these values that I passed inside a list. So this is how you create a series in Python, guys, using pandas. After this, I'm going to tell you how you create a data frame. So for that also, I'm going to tell you how you create a data frame using a dictionary object and how you can create a data frame using series as well. So now what we are going to do is we are going to create a data frame by passing a numpy array with a datetime index and label columns. So I'll take one variable, let's say date or dates. I'll just type it as D, and I'm going to take pd dot. So we're going to take the date range. And after this, I'm going to pass a few values, let's say 2020, and I'm going to pass values like we're in the month of March, so I'll just write it as March. And after this, I'm going to take periods, which is equal to, let's say 10. So this is my date range, guys. Okay, I have an invalid syntax, right? Should work fine now. So when I print D over here, so I have all these values in a date range format. After this, what I'm going to do is I am going to take one data frame, which I am going to take as df for obvious reasons to make it clearer. And I'm going to take data frame, and inside this I'm going to pass a few values. So first of all, I'm going to take a few random values. So I'm going to use np.random number, and inside this I'm going to pass 10, let's say 4. And now I'm going to get the index values as d, and I'm going to have to pass a few more values, which is columns. So I'll pass the columns as a list, and I'm going to take, let's say 4 columns. So I'm just going to take, okay, wait a minute, A, B, C, D. All right, do we have any errors? No. So now I'm going to print my data frame. So I have a data frame, guys, which I've created using, passing a numpy array, and I have a datetime index with labeled columns, which are A, B, C, and D. This is my index, guys, and I have all these random values using np array. So this is how you create a data frame, guys. Just a simple example, and I'm going to show you how you can create a data frame by passing a dictionary of objects that can be converted into a series also. So I'll take, let's say again, df is equal to pd dot data frame, and I'm going to pass a dictionary over here now. So I'm going to take a few values first of all. So first value is, let's say A. Now after this I have to pass something, right? Okay, I'm going to write, let's say a list of 1, 2, 3, and 4. After this, my next value is going to be, let's say B, and I'm going to pass a timestamp, let's say. And for timestamp, I'm going to use the same I have used over here, 2020 0301. I have to use the right. And after this, I'm going to pass one more value, let's say C, and I'm going to use a series now, a series object. And inside this, I'm going to pass 1, and the index is going to be, let's say, a range. All right, index is equal to a list with a range of 4, because we have only 4 values over here. We don't want any null values. And after this, I have to type in the data type as well, the data type of the series, guys. So for that, I use dtype is equal to, let's say, float 32. All right. After this, I provide my next value, which is d. Now for d, I'm going to use an numpy array. And for this, I'm going to pass a value, let's say, not 3, let's say 5 multiplied by 4. And let's take the d type is equal to integer 32. Yes. All right. Now I take my final value, which is going to be e. And inside this, I'm going to pass a data frame, or we're going to use the categorical object, guys. We're going to talk about this later on in the session, so don't worry. I'm just showing you how you can create a data frame using all these objects that we have at our disposal, guys. Now, instead of test and train, we can just call it as true or false. It doesn't matter. We are taking categorical object, so it has to be either true or false, or it can be 0 or 1, but it has to be decisive in a way that there are only 2 values. So I take another value, and for this, let's just say I give the value Edureka. All right, so our dictionary is done over here. So we have created our data frame, guys. There's no error. Now when I print this, so we have our data frame, guys. So A, B, C, D, E, and F. So we have all these values using different data types, or we can call it objects as well. So for that also, we can check the data frame, and we just write d types, and it's going to give us all the data types that we have. So we have date timestamps over here, integer, float, integer, category, and an object, because I have used a string over here. That's why it is giving us an object. But in the new release, that is Python 1.0.0, it's not going to be an object. It's going to show you it is a string. So don't worry, guys. And we have already made a video on Python Pandas 1.0.0 with all the features that have come with the new release, the new stable release released last month. You can check that out as well to check for the new features that we have come across. So now that we have done this, let us take a look at the next topic that we have, which is how to view data. So viewing data is basically, how you actually look at the data, or how you're going to look at the data using Pandas library. So we'll just jump right to Jupyter Notebook, guys, and I'll tell you what kind of functions or all those things you have at our bay that we can use to view our data. So we'll do one thing. First of all, we have data frames already that we have over here. So I'll do one thing. I'll just change it to df1 so that we have different data types, or I'm sorry, different data frames, guys. I'll run this, and this as well. Now when I check for df.dtypes, it should be different, guys, because we have already made a data frame using that. All right, it's not. So I'll run all the, wait. So I'll do one thing. I'll restart and run all the cells so that we have 2 different data frames. So first of all, the first very basic thing that you can do for your data frame is to use, I'll just tell you guys, you write df.head. So what this function is going to do is give you the first 5 values inside your data frame, or the first 5 rows. And similarly, for the last rows, you can use the tail method. So this is how you get the first and last values inside your data frame. So it's going to display all the 5 values that you have at your beginning and the end of your data set. After this, we have df.index. So what this will do is it will give you all the values from your index. And similarly, we have df.columns, which is going to give you all the columns from your data frame. So this is how you view your data, guys. And then we have DataFrame.toNumpy, which is going to give you a NumPy representation of the data. So I'll just tell you how you can do that. So I'll just write df.toNumpy. Wait a second, guys. Yes. So I'm going to create a NumPy array using this. I actually created a NumPy array. And for df, our data frame of all floating point values, DataFrame.toNumpy is actually fast and does not require copying the data. So it is a very best deal for we have. And then, okay, I'll just remove this. I don't want this. And then we have DataFrame.describe, which is going to give you somewhat like this, which is going to give you the count, the mean, the standard deviation, minimum, 25%, 50%, 70%, and maximum. So these are all values using the describe you can have, which is going to give you an idea or a perspective of how your data actually is and what kind of calculations are already there that you can think of. Then we have sorting by an axis. We can sort our data using an axis. So for that, you have to just write, okay, I'll just show you guys. You just have to write df.sort by index. And inside this, you have to give the value of the axis. I'll just give 1. And then let's say ascending, you want it to be ascending. No, I'll just write it as false. So it has given me the data frame by sorting the index. Similarly, I can sort it by the columns as well, or I'm sorry, sort it by values. So I'll write it as values, and I want to give the value as, say, values, and I'm going to give the value as, let's say, by. I want to sort it by C. It has sorted the values depending on C. So this is how you sort your data frame, guys. And now that we know how we can actually look at our data, I'm going to tell you how you select particular values inside your data, guys. I'm going to show you how you select a single column from your data frame. So we'll write df. It's very simple, guys. To get a value from your data frame using only a single column, you can write A or let's say C. So it's going to give all the values from C over here. It has actually given you frequency. It has given you name, data type as well. So this is how you actually get a single column from your data frame. Now let me show you how you can slice the rows as well. So for that, we're going to use the slicing. If you have actually worked on list comprehension, so we have slicing the data over here. We are going to follow the same principle here as well. So I'll just write df. Now I want my first, starting from my first value to third value. So it has given me only 3 rows, starting from the 0th row, and it has given me third row. And it does not actually include the third row because it starts from 0. So I'm giving 3 values. If I write 6 over here, I'm going to get the 6th value, but it's not going to be at the 6th row because the first row over here is going to be 0th row. I hope you understand this, guys. So I have shown you how you can slice your data, to get particular number of rows. Now let me tell you how you can select the data using the labels, guys. So for that, you have to use df dot, there has to be location, loc, and inside this you're gonna pass the values by labels, guys. All right, so let's pass d, that is, and 0. So let's see what the output is, guys. All right, so we have got all the values using the label, that is d over here, which we have passed over there in our previous section where we have declared the data frame. And I'm sure this is visible to you guys. Now the next thing is selecting data on a multi-axis by label. So what we'll do is we'll write df.loc, and after this we write hyphen, and we're gonna create, let's say, A, and we're gonna pass C, right? So it's gonna give me the values accordingly, which I passed over here. So instead of A, I can write B, or I can write D. So this is how you can select multi-axis using labels, guys. And I have written this over here, so I can just write, let's say, 0 to 3. Let's see what happens. Oh, we have an error, guys. You cannot do this. So we'll now move on to the next topic that we have is showing label slicing. Both endpoints are actually included. So how do we do that? So instead of this, we can just, let's say, copy this, paste it over here, and copy this, paste it over here, remove this. So this is just to show you guys how you can work with it. I'm very certain that the data that you work on is not going to be like this. It's going to be very complicated. So this is just to give you a perspective as a beginner how you can work with pandas. Now I'm gonna tell you how you can reduce the dimensions of the returned object as well. So for that, you just type one thing, guys. You remove all this, get just one value, and this is gonna give you the column number at over there. And this is how you get the values inside a data frame. So moving on, let's say we want to get a scalar value. So for that, we just write, okay, let's say D0. Right, let's see if it works. We're getting the same values, guys, only from the 0th row. For getting the fast access to a scalar, you can just write as df. Instead of loc, we can just write at. Okay, we have an error, guys. I'll just remove this and let's see if it works. Yes, so I'm getting the exact value at the 0th row at the column number C. Now I'm going to tell you how you select a value from using the position inside your data frame. So for that, we use df.iloc. All right, so let's say 3. Okay, so I'm getting all the values from third column. And similarly, we can slice the data. You can just get it like 3 to 5. All right, we can add more values to this, like 0 to 2. So this is how you select the values from your data frame, guys. Now we have Boolean indexing as well inside our data frames. So I'll just tell you quickly what it is. So for that, you just write df. Now I'm going to check if df column number A, let's say this is interesting, guys. So it has given me all the values inside A where A is greater than 0. If I write here, let's say 2, I have no values because none of the values are greater than 2. So this is how you can get the Boolean indexing. This is actually important when you're applying functions to your data frame, guys. So moving on, let's take a look at another method, which is isIn method. I'll just tell you how it works, guys. So it's basically is to check if the particular value inside your data frame is in there or not. Now there's one more thing. We can set new values inside our data frame. We can set a new column which automatically aligns the data by the indexes. So for that, we can make the series, and we can set the values by label. We can set the values by position, and we can set the assigning with a numpy array as well. And the result of the settings will actually align with the data frame, where a new operation with the setting can be followed, where you can simply align the data frame with the existing data frame. Now let's go ahead and take a look at the next topic that we have, which is handling the missing data inside your data frame. So let's jump right to it, guys. We'll go to Jupyter Notebook and we'll work with our missing values now. So pandas primarily use the value np.nan to represent missing data. It is by default not included in the computations, and we're going to see the missing value right now. So first of all, you have to reindex. You have to do reindexing, which is going to allow you to change, add, delete the index on a specified axis, so which is going to return a copy of the data as well. All right, I'll just take df2 is equal to df.reindex. So this is how I'm going to do the reindexing, guys. So index is equal to, let's say, d0 to 4. Yes, I'm going to get the columns after the reindexing, which is going to be equal to list of df.columns, and I'm going to add one more column, which is going to be, let's say, e. All right, now what I'm going to do is I'll do loc. I'm going to check a few values. So instead of dates, I've taken d, guys. So d of 0, and d of 1 at e is equal to 1. Now let's check what is df2, guys. We have two null values over here. So this is how I'm going to show you how to handle missing values inside your data frame. So we have done reindexing. So first of all, I'm going to check for null values. So we have true over here, and we can get the count as well. Is null, and we count these null values. All right. Right now we are going to drop a few columns. So we are going to drop the NA, that is the NA values. So as you can see from our data frame, all the values that had null values are dropped. Actually, the whole column has been dropped. Or we can do one thing, fill in the missing data, guys. Just do one thing. Okay, check df2 we have. So we can do one thing, we can fill the missing values, and we are going to provide some value. Let's say value is equal to 2, right? So we have actually filled the value with some other value. Wherever there is a missing value, we have given a value that is going to fill over there. So this is how you get, or check for all these missing values inside your data frame. After this, you can now actually get a boolean mask where values are NaN, which is null. So for that, you do pd dot is NA df2. So this is going to get you a boolean mask, which I've already told you how you can check using df dot is null. Same thing, but different processes to run this. Now let us move ahead and to the next topic that we have, which is Pandas operations, guys. Pandas operations are nothing but a few operations that you can apply on the data frame or any other Pandas object. So we have descriptive statistics that we can apply. We can apply functions, histogramming is there, and string methods is also there. So I'll tell you what histogramming is when we are talking about it. So let's take it up to Jupyter Notebook again, guys. I'll tell you how you can actually work with Pandas operations. So first of all, I'm going to tell you a basic operation, which is that is a descriptive statistics. So it's going to give us all the mean values. Similarly, we can get one value like df dot mean, provide one value over there. So this is how you get it, guys. Or we can write it as 2, right? All right. So this is how operating with objects that have different dimensionality and need alignment. In addition, Pandas automatically broadcasts along the specified dimension. So for that, let's make a series. I'll tell you just how it works. pd dot series, give it a few values. Let's say 1, 2, 3, np dot nan 5. I'm sorry, 4, 5, and then give the index value. The index is going to be dates, and let's just shift all this 2 places. Right, we have made an error, guys. Length of pass value is 6 and index implies 10. So we have to actually put more values. So write 6, 7, 8, 9. Yes. Now when I print s over here, we have all these values. Now we can do one more thing. So we write it as df dot sub, and we pass the s over here, which is our series, and we make an axis, write it as index. So we have operated with objects that have different dimensionality and needed alignment. So in addition, Pandas actually helped us automatically broadcast the specified dimension. So now I'm going to talk about applying functions to the data. So we already have data frame. Let's see what we have. So we have this data frame, guys. So what I'm going to do is I'm going to apply a few functions. So first of all, I'm going to use the apply method over here, and let's see what all do I have. Let's just check. We have absolute import, all close, a max, a minimum, angle, any append, all these functions that I can apply on this. So let's say we have 𝐶𝐬𝐮. Let's see what this does, guys. All right. So this is how it works. Now let's apply a few more functions, guys. So I'll write lambda x. So we are talking about lambda functions here. I'm sure most of you must be aware of the lambda functions that we have in Python. If you don't have any prior knowledge on lambda function, guys, there is a full tutorial on how lambda function works in Python, guys. So this is how we applied lambda function to get the subtraction between the x max and x minimum. All right. For all the columns, we have the subtraction between all these values. So this is how we apply functions to our data, guys. Now I'm going to talk about histogramming. So histogram is a representation of the distribution of data. So this function we have, which is matplotlib.pyplot.hist, on each series in the data frame, resulting in one histogram per column. So what we'll do is we'll make a series, and it's going to give us value counts for histogramming. How do we do that actually? So we can just write as dot value counts, right? Let's see if it works. Right, we have one value for each. So this is how we get or do the histogramming with our data, guys. Now I'm going to talk about the string methods. So series actually is equipped with string processing methods in the string attribute that actually makes it easy to operate on each element of the array. So let's just move ahead with the example. So I'll make a series, guys, pd dot, let's say series, and inside this I'm going to pass a few string values. So I'm going to start with Edureka, write Python next. Let's write Jupyter, give it a few null values as well to make it a little or slightly different from perfect. All right, so give it a few values, let's say football. And looking at the current scenario, let's write world. So we have a series over here, guys. Now what we'll do, we'll take or use the string methods. So I'm gonna make it all to lower, which are already lower. So I'll make it to upper, guys, upper letter words. So everything we have changed using the string methods inside our Pandas series. These are all the operations that you can perform on Pandas, guys. So let's move ahead to the next topic that we have, which is merging. So in merging, we are basically going to merge two data frames together. So we have two functions, which is concat and join. So concat pandas objects along a particular axis with optional set logic along the other axis. It can also add a layer of hierarchical indexing on the concatenation axis, which may be useful if the labels are the same or overlapping on the past axis number. So let's take a look at the example for this. So we have our data frame. I'm going to use pd dot data frame. Give it a few values, let's say np dot random number from, let's say, 10 and 4. All right, so we have all these values. Now what I'll do is I'll break it into the pieces. So how to do that? So let's say I write it as df2 is equal to df from first to third row. The next one is df from third to, let's say, seventh row, and then we have df from seventh to the end of the data. So this is how I am going to break it into the pieces. Now when I write it as df2, we have 3 data sets. Now I'm going to use the concatenation function using concat. All right, I'm gonna concatenate df2. So this is how I've concatenated the missing pieces, not the missing pieces, the several other pieces together using the pandas concat function. Now let's talk about the join function that we have. So for this, basically I'm going to tell you how you can do the left and right join. So for the left join, I'll write left is equal to pd dot data frame, and let's see, First value, let's say A, give it a few values, let's say 1, 2, and then say B, we have 3, 4. All right, we make the for the right as well. So I'm just gonna copy all this, paste it over here. Okay, I'm just going to write it as D. This is going to be, let's say, C, and change a few values. So we have left and right, and I'm going to just type left, and then we get the output for right. So I'm going to join all these two using the join function. So for that, I'm going to use the merge function, and inside this, let's say left, we have right, and on is equal to, I'm going to join it at let's say A. Let's see how it works. Okay, it doesn't. So we have a key error, which is A. So I'll change it to A, guys. So we actually joined using the merge function over here. And another example that I can think of is, let's say we have left and right. We can change the values differently, and we can just group them together. Now what I'm going to talk about is grouping, guys. So how you do the grouping of different data inside your data frame using pandas. So first of all, for that you have to split the data into groups based on some criteria that you have, and then after that you apply some functions on them, and then later on you can combine the results into a data structure. So first of all, you have to get a data frame, guys. So let's see, we have a data frame over here. So we can actually group it by, let's say, right, I'll just write group by, say, A, and I'm just gonna sum. Right, we have an error, guys. So we have a key error, that is A, because we don't have over there. So I'll write it as, let's say, 2. All right, we don't have 2 as well. We have a key error, we don't have 2 over there because it's not a string value, it's an integer value. So we have our values right over here. So we have grouped the data using the column that is number 2. Now we can actually group the data by multiple columns and form a hierarchical index. So for that, I'll just copy this, guys, or over here only I'll just do one thing, 2 and let's say 3. So this is how you actually combine multiple columns to form a hierarchical index. But here again, we don't have actually categorical values for these columns. If we had, we'd be able to do that. If we had, like, let's say true and false, it is going to have created a hierarchical index which will have different values for true columns and for false columns. So that's how you do the grouping, or that's where you actually need grouping using pandas. Now let's move ahead and take a look at the next topic that we have. Okay, we have already talked about operations, then I have talked about merge, where we have talked about concat and join, and then I've talked about splitting the data, how we apply the functions, and then combining the results together. Merging, we have talked about grouping. Now I'm going to talk about stack and pivot table. So what exactly is a stack, guys, in pandas? I'm sure most of you must have heard about some of the definitions of stack. So I'm going to tell you about this with perspective of Pandas library here. So the stack function is used to stack the prescribed levels from columns to index, and it returns a reshaped data frame or a series having a multi-level index with one or more new innermost levels compared to the current data frame. So you're going to understand this with an example. So I'm just going to take let's say my tuple is equal to, I'm just gonna take a list, and inside this, let's see, we have values, and we provide, or we get two lists over here, a list inside a list, guys. So let's take a few values, take 1, 2, 3, 4, 5, and then again, let's say 6, 7, 8, 9, and 10. or we'll add a few more values, guys. Let's say 11, 12 and 13. Over here I will add a few more values, let's say 17, 18 and 19. So we have our tuple. I'm going to create one more variable index. So we'll have multi-index. So from tuples, and inside this I'm going to pass my tuple, pass the names as well. So the names are going to be, let's say, first and second. So we have our index. Now I'm going to create the data frame, guys. So for this we write pd dot data frame, and inside this I'm going to pass a few values, np dot, let's say, random dot random number. So we have 8 values and 2 columns. All right, so and the index is going to be index, and columns is equal to A and B. All right, we have an attribute error, guys. I made a mistake. So there's no error now, and I'm going to make one more data frame. So inside this I'm going to pass this value. Now I check my data frame. So I have reshaped my data frame with this first and the second and all these values. Now we're going to talk about the stack method, guys, so which compresses a level in the data frame's columns. So we're going to do one thing. We're just going to do df2 dot stack. Right, this an attribute arrow. So this is how we stack or compress a level in the data frame's column, guys. And with a stack data frame or series having a multi-index as the index, inverse operation of stack is unstack, by which default it's gonna unstack whatever you have done with using stack. So we'll do df2 dot stack, and this is how you unstack. Now we'll talk about the pivot tables, guys. Oh wait, let's put it inside a variable, let's say A. Alright, so this is how you unstack, guys. We're getting different values there. Now we're going to talk about the pivot tables that we have in Pandas. So it is nothing but the levels in the pivot table will be stored in multi-index objects. On the index are columns of the result data frame. So we'll take a look at one example, guys, which is going to be pretty clear. So we'll take df again, pd dot data frame, and inside this we're going to take a few values, or we're going to take a list inside a dictionary. So let's go with a few values, let's say 1, or let's say A. All right, so we write A, B, C, D, we'll remove a few values over here, multiply it to 3. Now we take another value, which is going to be B, and for this we're going to take a list again. So let's say multiply it to 4, take another value, let's say C now, and inside this we're going to pass a few values again. So we're going to pass 6 values. So let's write P, P and P, Q, Q and Q, multiply it to 2 because we want the number to be 12. And now D is going to be np dot random dot random number, and the number we want is 12, and we take one more value e, and we take the same values for this as well. Random number 12. No errors, I guess. So we have an invalid syntax, guys. So we forgot to add a comma over here and here and here. Right, so I think it should work fine now without any errors. So we have printed the data frame over here, guys. So this is how it looks. Now we can produce pivot tables from this data very easily, guys. The very reason of creating this data frame was to get the pivot tables. Now what I'll do is I'll just write pd dot pivot table, and I'm going to pass df over here. All right, df, and the values is going to be, let's say, d, and index is equal to a and b, and columns, let's say, is equal to c. So this is how you create a pivot table, guys. Now that we're done with pivot tables, let me talk about the next topic that we have, which is time series and categoricals. So we have done reshaping, merging, grouping as well. Now we're going to talk about the time series and categoricals. So Pandas has simple, powerful, and efficient functionality for performing resampling operations during frequency conversion, which is, for example, converting secondly data into 5-minutely data. And this is extremely common in, but not limited to, financial applications. So we're going to take a look at a few examples. And for categorical data that you collect can be either categorical or numerical. So numbers often don't make sense unless you assign meaning to those numbers. So for categorical data is when numbers are collected in groups or categories. And categorical data is also the data that is collected in an either or yes or no situation. For example, we have 0 or 1, we have true or false. So that's going to be the category over there. So let's take a look at a few examples to understand this, guys, the time series and categoricals. So we'll take a look at a few examples for time series. So first of all, what I'm going to do is I am going to make a time series, guys. So first of all, what we'll do is we'll convert the data into 5-minutely data. So it's very common, guys. So I'll just take the range first of all. So we'll take the dates. All right, I made a mistake. I'll just cut this. So I'll just run this again. We'll get one more column. And now what I'll do is I'll make one variable using the pd.date range. Yes, and I'm going to provide the range as, let's say, 2020 01 or 03 01. We want the periods is equal to 100, and let's say frequency is equal to s. All right, let's print dates. Okay, so we have dates over here. I'll just remove this for now. So now we take one more variable, let's say ts is equal to pd dot, I'm going to take a time series, and inside this I'm going to use np dot random and random integer, which is going to be 0 to 500, and the length is of dates, and then we have index is equal to dates. So we have, okay, we have number attribute, no random randint. All right, so we have an unsupported date time, so I'm going to have to change this over here. So we'll write it as, let's say, 3 1, or we're going to write 3 3 2020. Right, so let's see if it works now. It doesn't. So we are getting the unsupported d type. Okay, so we just mention a few more stuff over here. So we'll write it as 0000 So I think I figured out the problem over here. So I've changed this to this format, and now I'm gonna add one more parenthesis here and remove this one. And now I'm not getting any errors, guys. So I'll run it again, right? So now what I have to do is I will have to make a few changes to that TS, which is time series I've made. So I'll write it as ts.resample, and I want to make it to 5 minutes, right? And I have to sum this. So no errors there, guys. So now I'm going to do the time zone representation. So for that, I'm gonna get one more. Okay, I'll just copy this, guys. This little change to this only. So I'll just copy this, paste it over here. And here, I have to make a few changes. That is 0, 0. The rest, everything is going to be fine. And we'll change this to 5. All right. So now we make another timestamp, and we just use pd dot series, and inside this I'm going to use np dot random dot random number, and the random number is going to be the length of dates and dates over here. All right, so now when I print timestamp, I'm getting the output as something like this. So this is how you get the time zone representation, guys. So you're getting the date, the time, and everything. And the data type is float 64. And then you can also get the UTC as well. So for that, I'll just write TS UTC, and we just write timestamp dot TZ localize, and we get UTC, right? It's UTC. Now I'm gonna print this, so we get the UTC as well. So this is how you create the time zone representation. And now after this, I want to show you how we can convert to another time zone. So for that, we don't have to do anything. We just write ts dot, all right, ts UTC dot TZ, which is time zone convert, and we write US Eastern. So we have converted into the US time zone. And converting between time span representations also, we can do that. Let's just say that's your exercise. So you have to convert between the time spans representations so that you'll be able to understand this better. For that, you don't have to do anything. You just have to take the date range. The period is going to be 5, and then you write the frequency. Instead of S, you write it as M. The rest all is going to be the same, guys. Okay, I'll just do it here as well. Just copy this, paste it over here. Instead of S, it's going to be M, where I have to remove this. All right, now I make the timestamp, which is going to be the same, guys. Now print the timestamp. This is how we convert. Or after this, we take one more variable, let's say PS, and I'm going to do period. All right, now when I print PS over here, this is the output I get. So the frequency is M. I've changed the frequency, and now I can just convert it to timestamp, guys. Let's see where it is. This is how you create it into a timestamp. Now converting between period and timestamp enables some convenient arithmetic functions to be used. So for that, we have period, range, and all those things that you can add. Now moving on to the next topic, that is categoricals. So for that, let me just take one more data frame, guys. So I'll write it as df is equal to pd dot data frame. Now I'm going to take a few values inside this dictionary. The first is going to be, let's say, ID. And now I'm going to pass a list with a few values, precisely 6. So I'm going to use 6 values over here. Now my next topic is, or the next key is, let's say raw grade, or just grade we'll write. So we're going to write A, B, C. Let's say again the guy is getting B and this one's getting A. So we have 5 and one more. Let's say one guy has failed. So we have our data frame. Let's print this. Okay, so we have our data frame. What I'm going to do is I am going to get the grade, right? So we'll get the grade is equal to df grade. Now this is going to be the category I'm going to make. All right, now we print df grade. So we have grades like A, B, C, B, A, E. Now I'm going to rename the categories to more meaningful names. So what I'll do is I'll make the change over here only. So I'll write cat dot categories, and I'm going to write the categories as, let's say, good. Instead of pass fail, I'm just going to write very good, and then there is excellent. All right, so we have very good, very bad, and excellent. All right, we have an error, guys. There's something we have done. So we have new categories needs to have the same number of items as the old categories. So how many categories do we have over there? Let's just copy this. So we have categories 4. So we're gonna have to make 4 categories, guys. So I'm just going to add good as well. There shouldn't be any errors. Now what I'll do is I'll just set the categories. So I'm going to set the categories now. Let's say here I'm going to have to give 6 values, guys. So right, very good. Let's say bad, very bad, medium good, very good. Any sort of categories I have to give over here. So I'll just write very bad, good, and let's say medium. All right, so after this I have set the categories as well. Now I'll just write df grade. Okay, so we have good, very bad, then we have very good, very bad, and good, and then we have NaN because we have not given any other category for that. And we have the 5 objects, so we are getting very good, bad, very bad, good, medium. So that's how you use the categoricals in pandas, guys. Now I'm going to talk about plotting using pandas. So that's going to be very simple, guys. For that I'm going to have to import one more library, that is matplotlib dot pyplot. I'm going to use it as plt. All right, same thing goes with this as well. All right, this is going to be pyplot. All right, so there should not be any errors now. Okay, so I will close all. Now I'm gonna make one series, guys, And inside the series, I'm going to provide a few random values like np dot random number until, let's say, 1000, or let's say 500, or yes, 500. And the index is equal to pd dot date range. I'm going to take the date range as 1/3/2020, and let's take the periods is equal to 1000. Wait, we have to take it as 500 because we have 500 values over there. I hope no errors. Yes. Now I'm going to take the timestamp and we're going to get the sum. All right, now ts dot plot. So we have a plot over here using pandas, guys. This is how we have created one series using the random numbers from NumPy library, and using the pyplot we have plotted a graph for random values which we have taken from 0 to 500 and the random range as well. So this is how you take or get a plot using pandas, guys. Now last but not the least, we have another topic which is reading and writing to files. So inside this, I'm going to show you how you can read from a file and how you can actually create a file over there. So we have our data frame, guys, or we have our TS. This is our TS, guys. So I can just, convert it to a CSV file, guys. Make it or give it a file name as, let's say, ts.csv, and it's going to save the ts.csv file somewhere in my directory. And similarly, I can read from a CSV file. So for that, I can just write pd dot read CSV, and I'm going to have to give the file location for that. So I'll just copy one file location from one of my data sets. So this is one data set that I have. So I'm going to check for the properties, or wait, I'm going to copy this, paste it over here. Okay, we have an Unicode error, so I'll just write R over here, and I'm able to read from the CSV file, guys. Look at this. Instead of CSV, I can write Excel, and it's going to create a Excel file or a CSV file it's going to read from. So that's how we actually read and write from files, like a CSV file, which is a comma separated file basically, or we read from a file. Now that we have come to the end of the session, guys, I hope everything discussed in the session is clear to you guys. You can freely drop your doubts in the comment section to reach out to Edureka community to post your queries. Thank you and happy learning.